Hello guys, welcome back to our channel, and this is the fourth video in financial data analysis series. And in today's video, we are going to explore the advanced concepts of NumPy and Pandas library in finance domain. So we'll learn about portfolio optimization, option pricing models, risk analysis simulation, moving averages, performance analysis, VAR calculation, along with fundamental data analysis of financial data. So let's dive into this code and understand how it works. So the first concept is from the NumPy library, and here we have the code of optimizing portfolio returns by balancing risk and expected returns. The first step is to define the expected returns, covariance metrics, and risk tolerance. These values represent the historical returns, the level of interdependence among different assets, and the investor's willingness to take risks. Okay, so moving on, the code performs portfolio optimization using the concepts introduced by the Markowitz. It starts by defining an objective function called portfolio risk, which calculates the portfolio risk based on the given weights. The goal is to minimize the risk while maximizing the returns. Additionally, we created a function that is called constrained sum of weights. Is defined to ensure that the sum of weights is equal to 1, indicating a fully invested portfolio. This constraint ensures that the optimization process yield valid results. Okay, so to perform the optimization, the code uses the SciPy library minimize function. It sets the initial weights as equal weights for each asset, and then it starts calculating the optimization for your stocks. So after we performed the optimization by using the minimize function, and it has its objective function, initial weights, methods, bounds, and constraints. The result object contains the optimized weights, and which represents the optimal allocation of assets in the portfolio. This code then calculate the portfolio returns and risk based on the optimized weights and print out the result. And as you see, it selects what return you could get in less risk, which is around 0.05%. Okay, so let's go to the next code. Let's dive into the code and understand how the Black-Scholes model work. As you just see, we start by importing the necessary libraries, NumPy and SciPy. The Black-Scholes function is the heart of the model. It takes input such as current stock price, strike price, risk-free interest rate, volatility of the underlying asset, and time to maturity. This function calculates intermediate variables, that is D1 and D2. Using these intermediate variables, the function then calculates the call and put option prices, like when you try to buy and when you try to sell. It utilizes the cumulative distribution function of the standard normal distribution to determine the probabilities associated with option prices. So in the next thing, we just see that in the Black-Scholes function, we have a stock price of $100 and a strike price of $105 and a risk-free interest rate of 5% with the volatility of 20% and the time to maturity is of 1 year. So we call the Black-Scholes functions with these inputs, and it returns calculated call and put price options. These prices indicate the value of buying or selling the options based on the current market conditions. Finally, we will print the call and put option prices to the console, and there you have it. The Black-Scholes model provides a mathematical framework for valuing options, allowing traders and investors to make informed decisions in financial markets. I hope you understand the Black-Scholes function completely. Okay, so the next we have a Python script that performs Monte Carlo simulation for risk analysis. Before we dive into the code, let's quickly understand the concept of Monte Carlo simulation. So Monte Carlo simulation is a technique used to model positive outcomes by substituting a range of values known as probability distribution for the factors that have inherent uncertainty. So it is basically used to simulate your future predictions. So it's named after a famous Monte Carlo casino known for its games of chance. In our code, we will be simulating the price evolution of a financial asset over a given period of time. So let's just break the code step by step. Okay, The first thing we have, we define some variables such as initial price, drift, volatility, time horizon, number of simulations, and the number of time period. These parameters are essential for our simulation. Next, we generate daily returns by using the np.random.normal function. This function creates an array of random values following the normal distribution, representing the daily returns of our asset. We adjust the drift and volatility to fit the time horizon and number of periods. With the daily returns generated, we use the np.comprod function to calculate the price series. This function cumulatively multiply each daily return to obtain the evolving price over time. Finally, we extract the final price from the price series and calculate the mean and standard deviation of these prices. We then plot the final price by using the matplotlib library, and there you have it. With just few lines of code, we conducted the Monte Carlo simulation for risk analysis and visualized the final prices of the simulated asset. Okay, so I hope you completely understand these three advanced programs of the NumPy library. So now let's move to the Pandas advanced concept. Okay, so the first code we have is about the moving averages. So let's understand what are moving averages and why they are used in the financial analysis. So moving averages are statistical calculations that help smooth out fluctuations in data over specific time period. They are commonly used in stock market analysis to identify trends, potential entry or exit points for trades. In our code snippet, we have a Pandas data frame called DF that contains a column named price representing the daily closing price of the stock. We will be calculating the 50-day and 200-day moving average on this price data. So let's take a closer look at the code. The first line of the code calculates the 50-day moving average, and here how it works. We assess the price column of our data frame, then we apply the rolling function with the parameter of window 3 that specify the window size of 3 days. This means we will be considering the previous 3-day price for each calculation. Finally, we call the mean function to calculate the average of prices within the rolling window, that is 3 days. The result is assigned to a new column in our data frame. Similarly, the next line is calculating the 200-day moving average, and this time we specify a larger window of 5 days, which means we will be considering a longer time period for the average calculation. By calculating these moving averages, we can observe the trend in the stock over the period of time. By analyzing these moving averages, we can gain insights in the stock price trends and make informed investment decisions. Okay, so the next Pandas code is about portfolio performance analysis. This code starts by generating a sequence of dates using the pd.daterange function. These dates span over the period of 10 days, starting from January 1 with daily frequency. So the next random portfolio values are generated using the np.randint function, and these values represents the values of the portfolio on each corresponding date. Now that we have the dates and portfolio values, we create a data frame to organize the data. The next step is to calculate the portfolio returns. So this is done by applying the pct_change method on the portfolio value column of the data frame, which computes the percentage change between each value and the previous value. With the portfolio returns calculated, we can move on to analyze the portfolio performance. This code calculates a cumulative return, which represents the total return over the given period by taking the cumulative product of the returns and subtracting 1. Additionally, this code computes the annualized return, which provides the annualized measure of the portfolio performance. It uses the last cumulative return value to calculate the annualized return over the given period of 10 days, and that's it. The code snippets allow us to analyze performance of invested portfolio based on the product data. By calculating the cumulative return and annualized return, we can gain insights into and how well the portfolio has performed over the period of time. Okay, so the next code is about the event studies in finance. We generate random values for the stock returns and market returns by using the np.uniform function. These values simulate the variability of the returns around the event. Once we have our data frame, we want to focus on the data related to the earning announcement event. So we filter the data frame to extract only the rows where the event is earning announcement. So using pandas and Boolean indexing, we can create a new data frame that is called event df. And in this data frame, we try to calculate the abnormal returns around the event. Abnormal returns measure the deviation of the stock's return from the market returns due using a specific event. And there you have it in the new data frame column. Okay. So the next thing, we are trying to analyze the potential risk associated with the financial portfolio and calculating the value at risk at a specific confidence level. By calculating the standard deviation, we get an idea of how much returns of the stock in our portfolio typically vary from their mean return. So higher volatility means the higher risk. In our code snippet, we set the confidence level to 0.95, which correspond to 95 confidence level. This means that we want to calculate the value at risk such that there is only 5% chance of the portfolio experiences losses beyond the value at risk value. So the np.percentile function is then used to calculate the VAR. It takes the stock return value as input and calculates the value below which the given percentage of the returns falls. In this case, it calculates the value below which the worst 5% of the returns falls. And finally, we print the calculated volatility and VAR values to the console for analysis and further use. These values provide valuable insights into the risk associated with the portfolio. Volatility helps us understand the typical fluctuation in the data, while VAR gives us the estimate of the portfolio maximum losses at a specific confidence level. Okay, so next is about the fundamental analysis. This is a very short topic, and we created a data frame here, and we move on to calculate the financial ratios. The ratios being calculated here are the profit margin and return on equity. The profit margin is obtained by dividing the net income by revenue, while the return on equity is obtained by dividing the net income by shareholders' equity. And there you have it. We successfully learn about advanced concepts of financial data analysis and on financial data using Python, and along with the Pandas and NumPy libraries. These codes are already uploaded on GitHub, and a link is in the description for the GitHub repository. We'll meet in our next video that is all about the first project on financial data by using all the concepts that we have learned until now. So don't forget to like and subscribe our YouTube channel for the further updates. So happy coding, happy learning.